Welcome to SpaceSpace, fellow cosmic explorers. Today, we're diving into one of the most captivating questions of our time. Living on Mars, how close are we really? Imagine waking up to a rusty red horizon, two moons dancing in the sky, and the knowledge that Earth is just a tiny blue dot millions of miles away. Sounds like science fiction, right? But here's the kicker. It might be closer to reality than you think. The red planet has captivated human imagination for centuries. From ancient astronomers peering through primitive telescopes to modern-day scientists poring over data from rovers, Mars has always held a special place in our quest for knowledge and adventure. But in recent years, the idea of not just visiting, but actually living on Mars has gained serious traction. So, where do we stand as of November 22nd, 2024? Let's embark on a journey through the challenges, breakthroughs, and possibilities that define our current path to Martian habitation. First, let's talk about why Mars. Why not the Moon or Venus or some other cosmic body? Well, despite its harsh conditions, Mars is actually the most Earth-like planet in our solar system. It has a day length similar to Earth's, about 24 hours and 37 minutes. It has seasons, polar ice caps, and even the potential for liquid water beneath its surface. But don't pack your beach towels just yet. We're talking about a world where the average temperature is negative 63 degrees Celsius or negative 81 degrees Fahrenheit. Mars also has a thin atmosphere, mostly composed of carbon dioxide. While this isn't breathable for humans, it does provide some protection from cosmic radiation and could potentially be used to produce oxygen and fuel. But here's the catch. That atmosphere is about 1% as thick as Earth's. Stepping onto Mars without a spacesuit would be like trying to breathe at the top of Mount Everest, times 3. So, what are the main hurdles we need to overcome to make Martian living a reality? Let's break it down. First up, getting there. The journey to Mars is no weekend road trip. Depending on the alignment of Earth and Mars, a one-way trip can take anywhere from 6 to 8 months. That's a long time to be cooped up in a spaceship exposed to cosmic radiation and the effects of zero gravity. But scientists and engineers are working tirelessly on solutions. One promising development is in propulsion technology. Traditional chemical rockets are great for getting off Earth, but they're not ideal for long-distance space travel. Enter ion propulsion and nuclear thermal propulsion. These technologies could potentially cut travel time to Mars in half. Imagine going from an 8-month journey to just 4 months. That's a game changer. But even with faster travel, we still need to protect our astronauts from the harsh realities of space. Prolonged exposure to microgravity can lead to muscle atrophy, bone loss, and even changes in brain structure. Scientists are exploring artificial gravity solutions, like spinning sections of spacecraft, to mimic Earth's gravity during the journey. Then there's the radiation problem. Outside of Earth's protective magnetic field, astronauts are exposed to high levels of cosmic radiation. This increases the risk of cancer and other health issues. Researchers are developing advanced shielding materials and even looking into medications that could help protect astronauts from radiation damage. But let's say we've solved these problems and our intrepid explorers have safely landed on Mars. What then? Well, that's when the real challenge begins, actually living on this alien world. The first order of business, shelter. Mars isn't exactly known for its cozy accommodations. We need habitats that can protect against radiation, maintain a breathable atmosphere, regulate temperature, and withstand potential dust storms that can last for months. One fascinating concept being explored is 3D printing habitats using Martian soil. Imagine robots arriving on Mars ahead of human astronauts, scooping up the rusty Martian regolith and printing out homes ready for human occupation. It sounds like science fiction, but it's based on technology we're developing right now. Another idea is to use natural Martian features, like lava tubes, underground tunnels formed by ancient volcanic activity. These could provide natural radiation shielding and protection from the harsh surface conditions. But a habitat is just the beginning. We need to create a sustainable environment inside these structures. That means generating breathable air, managing waste, and perhaps most crucially, producing food. This is where things get really interesting. Remember that thin Martian atmosphere I mentioned earlier? Well, it's 95% carbon dioxide. That's bad news for human lungs, but great news for plants. Scientists are already experimenting with growing crops in simulated Martian soil and atmosphere. Potatoes, lettuce, and even hops, no Martian beer just yet, have shown promise in these experiments. But growing plants is about more than just food. Plants could play a crucial role in generating oxygen and recycling air in Martian habitats. It's a concept called bioregenerative life support, and it's not just about survival, it's about creating a little piece of Earth on Mars. Water is another critical resource for Martian settlers. The good news is, there's water on Mars. It's just mostly frozen in the polar ice caps or bound up in minerals. The challenge is extracting and purifying this water for human use. Technologies are being developed to melt subsurface ice and condense water from the Martian atmosphere. Now let's talk about energy. Solar power might seem like an obvious choice, but Mars receives less than half the sunlight that Earth does. Plus, those month-long dust storms I mentioned earlier, they can block out the sun entirely. That's why researchers are looking into other options like small nuclear reactors. These could provide a constant, reliable source of power regardless of weather conditions. But living on Mars isn't just about survival, it's about building a new society. How will Martian colonists govern themselves? What kind of economy will they have? How will they communicate with Earth when there's a time delay of up to 20 minutes each way? These are questions we're only beginning to grapple with. Some propose that early Martian settlements will need to be largely self-sufficient due to the difficulty and expense of resupply missions from Earth. This could lead to the development of new social structures and economic systems. Communication with Earth will likely rely on a network of satellites orbiting both planets, allowing for continuous data transmission even when Mars and Earth are on opposite sides of the Sun. But the time delay means that Martians will need to be largely autonomous in their day-to-day operations. Now, I know what some of you might be thinking. This all sounds great, but when is it actually going to happen? Well, that's where things get a bit murky. Various space agencies and private companies have proposed timelines for Martian missions, but these dates tend to shift as new challenges arise and technologies develop. NASA's Artemis program, which aims to return humans to the Moon, is seen as a stepping stone to Mars. The agency has stated its goal of sending humans to Mars in the 2030s. Private companies like SpaceX have proposed even more ambitious timelines, though these should be taken with a grain of Martian salt. But here's the thing, we're making progress every day. Each rover we send to Mars, each experiment we conduct in simulated Martian conditions, each breakthrough in propulsion or life support technology brings us one step closer to that red horizon. Consider this. Just over a century ago, the idea of human flight was considered impossible by many. Today, we have a rover on Mars that's not only driving around but has even flown a small helicopter. The pace of technological advancement is increasing, and what seems impossible today might be commonplace tomorrow. Of course, there are those who question whether we should be focusing on Mars at all. With so many problems here on Earth, why spend resources on settling another planet? It's a valid question, but I'd argue that the pursuit of Mars has benefits beyond just the goal of colonization. The technologies we develop for Mars missions have applications here on Earth. Advances in water purification, sustainable agriculture, and renewable energy could help address issues of resource scarcity and climate change. The challenge of living on Mars pushes us to develop more efficient, sustainable ways of living that could revolutionize life on Earth. Moreover, the pursuit of such an ambitious goal inspires new generations of scientists, engineers, and dreamers. It pushes the boundaries of human knowledge and capability. In striving to reach Mars, we may just find solutions to problems we haven't even recognized yet. But let's bring it back to our main question. How close are we really to living on Mars? The honest answer is, we're closer than we've ever been, but we still have a long way to go. The fundamental technologies required for Martian habitation are being developed and tested. We're learning more about Mars every day thanks to our robotic explorers. But there are still significant challenges to overcome. We need to perfect long-duration spaceflight and solve the problems of radiation exposure and microgravity effects. We need to develop reliable, efficient systems for producing food, water, and oxygen on Mars. We need to figure out how to build and maintain habitats in one of the most hostile environments humans have ever attempted to live in. These are enormous challenges, but they're not insurmountable. Every problem I've mentioned in this video has brilliant minds working on solutions, and with each solution, the dream of Martian habitation becomes a little more real. So, what do you think? Will you be among the first Martian pioneers, or will you be watching from Earth as humanity takes its first steps on the red planet? The journey to Mars is not just about reaching another world, it's about pushing the boundaries of what's possible, about daring to dream big and then making those dreams a reality. As we wrap up this cosmic journey, I want you to look up at the night sky, find that reddish dot that is Mars. Now imagine that one day, perhaps sooner than we think, there will be people looking back at us from that distant world. It's a future that's within our grasp if we have the courage and determination to reach for it. This is SpaceSpace, signing off from Earth, for now. Keep your eyes on the stars and your mind open to the incredible possibilities that lie ahead. And who knows, maybe someday we'll be broadcasting to you live from the surface of Mars. Until then, keep exploring, keep questioning, and keep pushing the boundaries of what's possible. The cosmos is calling. Will you answer?